All right, I guess we can get started. A little bit about us. You guys might have seen my other presentation, but my name is Rohan Nepomuceno. I am a senior at Davis Senior High School, and I've been a FRC 1678 member for 4 years. This is my ongoing 4th year. I'm the hardware electrical lead, and I've done our program, our outreach program, Citrus Service, for about 2 years. And I'll send to my co-presenter.
Okay, I'm Jasmin Shah. I'm a sophomore on FRC 1678, and this is my second year on the electrical sub-team. I'm the fall workshops coordinator for the past season, and I've been doing Citrus Service for the previous season and this season as well.
But yeah, so some basics about the FRC control system. So this has been the basic control system since 2015. It's stayed pretty much the same, but it's been updated throughout the years with the new developments such as the PDH, RoboRIO 2.0, Carnivore, and more new releases. On this is like a basic wiring diagram on the side. Other components not on this diagram can also be hooked up. It's not very rigid. The electrical systems on the robots are pretty fluid and they're pretty flexible. So you can basically add whatever you want if it's remaining within the rules of basically if it's not too dangerous. But yeah, things like Spark Maxes, Falcons, PCMs and stuff, we'll go through all that.
Okay, so the one thing that's possibly the most important part of your robot is the PDP, or the power distribution panel. So the PDP really starts from the battery. So in FRC, we use a 12-volt battery, and it's connected to the PDP using 4 to 6 gauge power wire. So there's a red one that goes to the main breaker, and this is like the on and off switch for the robot. And then from the main breaker, that red wire goes to the actual PDP. And then there's a black wire, which is like the negative wire or the ground wire, and that goes directly from the 12-volt battery to the PDP. So the PDP, as you can see, has 10 ports on either side, and each, the smaller ports use 30 amp fuses, and the bigger ports use 40 amp fuses, and each port kind of goes to a component, or like a component on the robot. So some of the components could be like motor controllers, Falcons, PCMs, VRMs, and Limelight. Okay, so the pneumatics is another part of the robot. The pneumatic system can be used to produce an action on the robot. So in past years, many teams have used the pneumatic system to kind of create an intake. So the pneumatics are with pistons, can be used to force something to be pushed out. So for the intake, that the intake portion would be pushed out using the piston, and then it would be brought back also using the piston, and that would be kind of like the intake system, or at least the basics of it. So the entire pneumatic system also includes the PCM, the compressor, and the power switch. So the PCM, or the pneumatics control module, is kind of like the PDP of the pneumatic system. So it's a CAN-based device, and it goes into the CAN loop, and it's wired to the RoboRIO over the CAN bus. It's also powered by the same 12-volt battery that goes to the PDP, or it's powered from the PDP that uses a 12-volt battery. Additional PCMs can be used. So PCM can power 8 solenoids, but if your robot were to use more than 8 solenoids, it would need additional PCMs. And it's protected by a 20 amperage fuse or a smaller circuit breaker.
Yeah, so what the PCM powers is solenoids, which are basically gates for air to pass through into the pistons themselves. So there's two different types of solenoids on FRC robots. It's the single action solenoids or the double action solenoids. And so basically the difference between the single action and the double action is single action gates are when you give them power, they'll open, and when they don't receive power, they close. Pretty standard. But for double action solenoids, when one side receives power, it will either open, or it'll open the gate for pneumatic or for air to flow, and then you need to send power to the other side to reclose it. So it's basically one's a single door, and then one needs 2 inputs to be closed. Keep in mind that on a double action solenoid, you do need to take up 2 slots on your PCM in order to like have it working. And yeah, and another things that go on the PCM include the compressor power. So the compressor receives power from a specialized port on the PCM labeled compressor. And also, along with the special ports, we have the pressure switch, which is also connected to a special port. The port on the PCM is actually blue and it's labeled pressure switch. And they're both the same color since pressure switches are dipolar. So it doesn't really matter which orientation you plug it into. It just matters that it's plugged in. And basically what a pressure switch is it detects the pressure of the stored power or stored capacitance of the tank, and then if it's too high, it'll turn off the compressor to make sure that we're not gonna have a blown up air tank.
Okay, so the VRM, or the voltage regulator module, is a buck boost converter. So pretty much, if there's too much or too little power, it can convert to the desired amount of power that we need. So we have 2 regulators on the VRM, the 5 volt and the 12 volt. And it's wired to the PDP using a 20 amperage fuse, unlike the bottom part of the PDP. And it's also used to power the radio, and also like sensors, so like encoders and other smaller sensors on our robot. And it's connected to the radio through the 12 volt connection. Okay, so motor controllers are kind of like the middleman between the motor and the PDP. So on most motors on FRC, you need a motor controller per each motor, and they kind of serve to make sure that your motors are safe and they don't use too much power. They're receiving the right amount of power from the PDP. So some common motor controllers in FRC are the Spark Maxes, the Talon SRXs, the Victor SP, and the Victor SPX.
And a little note about motor controllers is, so the Talon SRXs and the Spark Maxes both have implemented encoder ports. So you can actually hook up your encoders onto the Spark Maxes and Victor SPXs by themselves. You don't need additional CAN work with that. And then I believe the older models of the Talon SP, or the Victor SP, still use PWM. So if you're running PWM still, like, it's a good option for the old Victor SPs.
Oh, and also the Falcons don't use any motor controllers because they have built-in motor controllers. Okay, so we have various wire connectors in FRC. So some common ones are Anderson, and that's like the one that's used to connect the battery to the PDP, or like the main breaker. We also have ferrules that are used for the PCM and the VRM. They're kind of like the smallest ones, and they're used for smaller wires, and they aren't always necessary, but they are a safer option when you're using the VRM or PCM. We also have the lever nuts. This is kind of a newer thing that's being implemented in FRC, and it's a lot of teams use them for the CAN connections, and they're a really great alternative for soldering or using PWM connections because they're really quick and they're pretty reliable. Oh, and we also have the PWM connections. They're not on the picture over there, but pretty much there's a female and male, and female connects to male, and there's 2 on each side. So there's one for yellow and one for green when you're using CAN loop.
Yeah, and some specialized connectors that we use on our robot include the lug compression connectors, which are basically just the ones we use on our batteries to hook them from the battery to the battery terminal, or the power wires to the battery terminals. Those are basically just really long like connections that have like a hole in them, so you can put a bolt to lock it in. And we also use them on our connections to the PDP. And so those are basically just like really chunky, like durable connections. We also use ring terminals on components like our pressure switch, because they have ring connections as well. So just put two and two together, and basically you just screw them in, and it has a similar effect to the lug compression connectors.
Okay, so wiring practices. This is really important because when you're at a competition and something goes wrong, you really want to be able to have a clean and well-wired robot so you can figure out the issue and solve it as quick as possible. So some things that you want to keep in mind when you're wiring the robot is always to label. Especially when it comes to the PDP, you want to label what each port is doing. So what, like the wires that are coming out of each port, label them, what motor they are, and also label the motors or like the wire coming out of the motors and label what that motor is doing. And we try to wire straight out or at a 90-degree angle. This kind of helps to make sure that nothing is rubbing against each other, especially when we're actually driving and something gets hit or whatever. And another thing is giving your wire some slack or some extra room. This is great for when you need to make a really quick change and you can't make a extension. So having that extra wire just kind of gives you some leeway. Of course, to keep it clean and use zip ties. So zip tie everything down. Again, if you're actually moving around and if something gets caught in the bottom or something isn't like directly zip tied down to your robot, it can kind of get rubbed against other things on the floor or on other robots. And of course, communicate with your team, know what you're doing. Make sure that everyone's actually doing something to make sure the wiring is clean and uniform.
Yeah, so for our wiring practices, we like to have a standardization of all our practices. So in the case that someone drops like what they're working for a moment, then someone else can quickly pick it back up and see exactly what they were doing, what they were working on, where it goes, and basically it just makes it a lot easier for people to understand what you're doing and why.
Okay, so the RoboRIO is the brain of the robot, and it's what connects electrical to software robot.
Yeah, so the RoboRIO has a lot of flexibility with what it does. So they have like tons of ports on the RoboRIO, including the RSL, Ethernet, the USB host, and power. And so like these are just some of the basic ports that you'll be using in order to get your robot working. And so start off, we'll talk about RoboRIO power. So the RoboRIO takes inputs from 7 to 16 volts, and so when it doesn't receive that like desired voltage, it'll enter a brownout mode. So when voltage drops to around 4.5 to 6.8, basically all processes will just go down, and they'll start tanking. So that's like a real reason why we want to make sure that the RoboRIO has constant and consistent voltage, is because if there's not enough voltage supply, basically the CAN loop starts to like die, your signals start to die, your radio really doesn't communicate well, and then like your sensors don't have inputs or anything. So it's just a big hassle, and like at that low voltage, you risk damaging parts, even if it's a lot lower than what it could handle. Okay, so yeah, we'll get into CAN. CAN stands for Control Area Network, and basically what it is it's a communication form that uses nodes over the CAN bus or CAN network. Each CAN component on the robot has basically a little processor and a microcontroller to basically receive whatever inputs are on the CAN loop. So basically, like what'll happen is each little processor will receive all the same information. It's just the processor itself will take in a portion of that information and act based on how it's told by the RoboRIO. And that's why you have to ID each component separately, is because each ID is basically lets the component know what it should be reading out and like what it should be like actually doing. And that's why you should also make sure you have IDs and make sure you guys aren't doubling up on IDs, because once that happens, problems start to rise where components don't know what to do. So you might have already seen this, but this is like a basic CAN loop, I guess. So the yellow wire is the voltage in, or the signal wire itself. So that, like if you're gonna keep any wire like good, keep the yellow wires good, because that's where the data is transferred over. And so basically, they can just be routed from node to node to node, and it'll stay pretty consistent. And on the right, you can see what a CAN node like processes looks like. So what will first happen is the signal will be transferred to the CAN transceiver, and which will go to the microcontroller and the CAN controller. And at that point, once it's done translating like what it should be doing with the transceiver, it'll basically do the actions it's told, and then it'll go back into the CAN loop to basically go into the next component. But with CAN, it's a lot simpler. It's a lot cleaner. Things don't have to go to a central area, so there's not like a cluster of wires going all into the RoboRIO. It makes the central processing not so central in order to let it have flexibility in working around a FRC designed robot. And on the right is just it's just a demonstration of like the cleanness of CAN wires. They just hopping from one to another, and we often call them daisy chains because they look like the yellow and green wires look like daisies. This is like a basic CAN bus. So the most important components on your robot all hook up to CAN bus. And so it's like it starts from the RoboRIO, and then usually it goes from the RoboRIO to like something like the PCM, and then it'll be terminated at the terminating resistor of the PDP. There's also a terminating resistor on the PDH. They both do the same thing. But basically, the terminating resistor will mark the end of the CAN loop, and then the voltage back will basically be ready for the next cycle of signal.
Okay, so the canifier is essentially kind of like the converter for digital information, and it converts it into the CAN loop. So the canifier is used for LEDs, and when we use it for LEDs, we pretty much have no need to use like the sensors, and this helps us to kind of save ports on the DIO ports on the RoboRIO. So this way we can add more sensors to our robot, like a proxy or a color sensor.
Yeah, recent processes of the canifier have been, I guess, taken over by newer components. But the thing that makes a canifier so useful is the fact that it's not quite specialized, and it's more unique in the fact that it can do almost everything. It's more of a general tool. So like things like the candle or just the ports on the RIO can all be done by the canifier itself, and it doesn't need a hyper-specific component, which introduces more problems oftentimes. So it's a very nice and simple, clean solution to basically ending out your CAN loop and connecting signals. All right, I2C. So as you guys might know, the RoboRIO has an I2C port, and basically what I2C is a simple protocol to talk to sensors. So the I2C process has one master and three slaves to basically communicate between each other, and it has all these processes to make sure that all the signals you're receiving are running correctly. So we do use these for lights and stuff, and so basically it's just a really funky way to go through sensors, or to code and communicate through sensors. And they are used on such things such as Arduinos. So you can actually hook up your Arduinos through the I2C port. This is a basic, very basic, idea of what the I2C processing does. So you have the master and the slaves, which all basically help you communicate through I2C itself. And I2C is notoriously hard to code. So what often happens is we forego using I2C and completely skip over it by using things such as the Canvor, or I'll get into it later, but expansion boards and such.
So the DIO stands for the digital input and output, and it's used for sensors to kind of get their information. So it has two statuses, on and off, and it's all received by the RoboRIO. So it's used for proxies and Hall effect sensors. As I said before, the DIO stands for the digital input and output, and it is a control type that can be used for sensors.
Yeah, so I guess to get a little bit more gritty and deep into what DIO is, it's considered a Boolean signal, and basically Boolean means it has two statuses of true or false. And so, like, what will be received by the RoboRIO is either a 1 or a 0. And basically those 1s or 0s will tell it, oh, something's here or something's not here, or however you interpret that, or however you want the RoboRIO to interpret it. Alright, so PWM. So PWM stands for pulse width modulation, and is basically when you want to like cycle through like zero voltage and like a number that you want. And so what will happen is these little pulses will average out to a certain voltage, and the amount of period of time that the voltage is, and the voltage itself that's regulated, or that's like flipping between, will basically give you certain kinds of signals. And so there's a lot of variation within PWM, even though it seems quite simple with the either 0 or 1 kind of system. So like the 3 pins on PWM are either the voltage, ground, and signal back. And so that's why there's 3 ports, and sometimes we just use 2, depending on the component. And it's used for signals that are mostly analog. So either things that are like in between, or not quite digital, but not quite linear, such as, or not quite Boolean, I guess you could say. But yeah. Relays. Okay, so relays are 5-volt controllable outputs on the forward and rev pins. They're very, very, very uncommon to see nowadays, as you know, as the new parts have been released and just they kind of been phased out due to their inconsistencies. The main reason they still keep it is because that's how it was initially designed. But like the ground pin is like the only one that isn't the forward or rev. And so they're used for components such as the spike, which was very common in around 2015, I'd say. But since then, it's kind of phased out. So you don't really need to worry too much about relays and how they like affect your robot. But yeah, going like, so what I was talking about earlier about MXP expansion boards. So basically, MXP expansion boards are just like add-ons to your RoboRIO, and so they allow you to connect basically whatever kind of microprocessor or microcontroller onto your robot through the like middle rectangular port of your RIO. And so like a couple common ones are the digital boards, the Rio Duino, and so like what we did in past, or not past years, this year, what we did was we connected a Pi Pico in order to basically skip over receiving signal from our color sensor and taking it from the I2C. So we skipped over I2C and just went straight from the Pico to the Rio itself in order to make to make it easier for our programmers, because I2C is very, very inconsistent with inconsistent in general. But yeah, so MXP stands for My RIO Expansion Board, and so like those are the pinouts. They all have like a specialized like duty, but like basically it's just it's basically a free land to whatever you want to connect to your RoboRIO, and it can do anything from analog inputs, DIO, and UART. Well, you guys know what UART is. It's basically just a transmission between microprocessors. So introduction to sensors. A sensor is a device that detects or measures a physical property and records its indicates, then sends out an output. And so I'll hand it off to Jasmin.
So why use sensors? They can be used to for feedback or positioning robot parts. So some sensors that we use to do that is potentiometers, encoders, and light switches. We can also use it for motion control. So for that, the sensors are drive chain encoders, gyroscope, and accelerometer. And detecting field elements in and out of the robot is another thing that we can use sensors for. And the sensors used for that are mechanical limit switch, proxymeter sensors and vision, like
Yeah.
limelight. Yeah.
So to basically like I guess the rundown is potentiometers measure the angle of which a rotating part is at. So it can tell the difference between like a 30-degree angle to a 90-degree angle based on the resistance that it reads. And so we use those a lot. Well, not as commonly anymore, but we use it a lot on our motors sometimes when we want a specific angle on things such as like lever arms and such. Limit switches basically just detect if something is hitting the switch or not. It's usually activated whenever you hit a limit on a movement, and so it basically tells your RIO like, oh, we've hit this area in space. You can either power off this component or whatever. For the motion controls, drivetrain encoders basically count the amount of rotations that your motors do and sees basically how much they're spinning, how fast they're going, and such. And so, along with gyroscopes and accelerometers, gyroscopes can tell what position position you're in, and like kind of like how you can tell how balanced you are. And then accelerometers tell how fast you're going. So with the combination of the encoders, gyroscopes, and accelerometers, the robot can basically tell exactly what it's doing, where it is, and sometimes that's what we use for our autos and such to make sure that we have exact precise like area control during our autos. Field detecting elements, like mechanical image switches. If you hit it, you just know you're there. And proximity sensors basically just tell you. They're a good example of proximity sensors are our beam brakes. They're kind of like your garage doors, if you ever mess around with those. And so they send out an IR beam, and if you break that beam, it'll tell you that something's in that like area of vision. And sometimes we just use vision. Cameras are really useful. In previous years, with 2019, I believe, we used vision cameras to basically sense what we were doing during the autonomous period where we were unable to see the field. All right, so choosing a sensor, sensors like have all different kinds of outputs. So Boolean once again is true or false. So if you just need your RoboRIO to know like yes or no, then you'd use a Boolean type switch or Boolean type sensor. Analog or digital. So basically, that's analog is from anywhere from 0 to 1. So we can read like census stuff from like on a scale of 0 to 1, and so it can like read values such as like 0.5, 0.2, and like it can get all those in between values, while digital can only read values of 0 to 1 for a period of time. Serial is more like code and like environmental like understanding like sensors. So that's things like your Hall effects. And so yeah, they are basically used for like telling the robot like what's going on around it. And they obviously have electrical requirements, so they would need to be hooked in through either the PWM or DIO ports on your RoboRIO. And so you basically want to check that those have the correct like limits for what the RIO supplies, because we've run into problems sometimes where our sensors will not have enough power, or they'll basically blow up in our face because we supply with too much power. And obviously the price range, you can get a super expensive sensor, but since they're so fragile, it might go to waste since you just like break it while you crash your robot into something. I guess I've already gone through the mist switches, but yeah, I'll go through Hall effect sensors. So Hall effect sensors are basically, they detect magnetic fields. So what they do is they're basically a magnet, and whenever another magnet is like around it, it'll sense that, and it'll change. It'll basically send out a signal like how close this magnetic field is, and so they're like really good replacements for limit switches because the limit switch itself can break, but like magnets are like pretty consistent no matter how hard you like smash them together. But yeah, Also, just magnets themselves are more reliable than having like a physical barrier. But yeah, encoders. Once again, they're basically they just tell you how much rotations you're doing per second, and they use the magnets. So they use magnets, or we call them mag encoders. So what they do is when a magnet rotates, its magnetic field rotates as well. And so that change in magnetic field is detected by the encoder and basically gives us a number, like it's rotating like 5 times a second. But yeah, and the potentiometers are used once again for like see how far we've done something, or in rotational capacity. Gyroscopes are serial, so there's the more complicated like coding. But they also detect angular motion, so they can detect like what your position is in like I guess in space, like tilting wise. So if you want to use it for elevators and such, those are really good to like see exactly or how far you've like tilted yourself. And then accelerometers basically just tell you if you're accelerating or not. And proximity beams are like your garage doors. Sensor boards themselves are basically just like a whole bunch of sensors put together on a board. Pretty crazy. And so like a good example of this is the Pigeon IMU, or the Pigeon 2.0, which has recently been released to the public as of last year. But basically what happens with these is the Pigeon is a combination of accelerometer and a gyroscope. And so it's a really good like one board solution to like most of your problems. And the best thing is that it connects straight to CAN. So it's very, very reliable, and you can even hook it up to your speed controllers and such if you have a moving component on that. But yeah, implementation. So since sensors are so fragile, since they're quite literally made to detect things at a precise moment, like you want to protect them. Like oftentimes teams will have pre-made 3D printed like mounts for them, and so if you guys go like onto like any place, you'll probably find at least one mount for the components like the Pigeon have really common and really popular mounts. And so like also I forget where it is, but you can also 3D print like mounts for your like RoboRIO and such. So I'm still looking into it, but like it makes sure that you basically have protection on all your very important components of your robot. And yeah, another thing about implementing sensors onto your robot is to not solder them together. So soldering is very reliable to keep a nice firm connection on your wires. But what often happens is soldering wires together often introduces resistance into your sensing. And so what resistance does is basically makes the signal a bit blurrier or a bit less precise, or straight up drops signals from sensors. And so like if you have resistance introduced into your sensor loop, then it's basically ineffective. And so what will often happen is we use surface contacting crimps and such, like the terminal ones in the male and female crimps. Noise is also a pretty big problem. So when high currents of like there's high currents like around your sensors with things such as like coils of wires, the electromagnetic like fields will kind of screw with the signal of your sensor. So with really sensitive parts like the electromagnetic sensors, is to basically just like have very little coils around them. And so like basically you want to have enough slack to have your robot move freely, but not enough to interrupt with your sensing and such. So interface types. So DIO, it's very easy to interpret and to use. So it's often more for simpler applications. Analog, like I said, has a range of like sensing capacity, and so it's a lot more it's a lot better for like in between values, but it's very susceptible to noise, as it is getting those input values between like it tries to be very precise, but it gets quite interrupted by noise. And then digital serial, it has really good resolution because it's very precise with the on and off in duty cycles, but it's a bit more complex to utilize.
Okay, so the future of FRC control system. In February of 2020, first announced that they would be like creating a new control system for the 2022 to 2026 season, and the components that they were releasing were provided by the National Instruments and Rev Robotics. So some of the things that the new things that they created and gave to us were the RoboRIO 2.0 and the PDH.
But yeah, as it being not 2026 yet, we're looking forward to new releases for the wiring wiring systems of our robot. And so I think next year they have yet to unveil a new component. And so they are on schedule to keep updating until 2026. And so yeah, they're basically just updated versions of the current, or so far at least, they're just updated versions of the current components. And so like they're just like upgrades, but you know, we still like to see it, and we are very excited to see what's left for the future of FRC. You can email me at Rohan Nepomuceno, or rohannepo@gmail.com, and thank you guys very much for listening to our presentation. But yeah.